So welcome back to another UVM tutorial, and this time we will be talking about active and passive agent. So in UVM based test bench, you have an ability to make any agent passive or active. So what is the difference between an active and a passive agent? So in an active agent, so active agent, it's like any regular agent in which you have an agent, and agent has three components, and those three components are sequencer and sequencer which manages the handshake going on between the sequences and driver, and the driver which will basically drive the data to the duty, and a monitor which will collect the response from the duty and pass it to the scoreboard for checking. So in an active agent, you have instance of all these three components. But in an passive agent, you have only a single component instantiated, and that is monitor. So you might ask that why are you going to use an passive agent in which a passive agent in which you have no instances of sequencer or driver, and how will that particular test bench even work? So a passive agent is usually used uh, in the case of reusability at higher level of integration. Let's say you design uh, an UVM based test bench for a certain submodule at certain level of the hierarchy, at a lower level of the hierarchy, at a component level, and you verified that particular component. But after that, you integrate that particular component in at SOC level. So at that particular level, you could not use you will not be using the same sequencer or driver for driving the data, because that particular module has now become a subcomponent at the SOC level, and it will be getting its input from another module. So in that case, what you want to do, you don't want to have a separate driver or sequencer for that particular module, which has become a submodule. So in that case, you just want to observe the output of that particular module, because the driver in that case is another submodule. So let's say at comp level, you have uh, a module A, and you have verified that using a UVM test bench which has an active agent. Now, uh, at higher level, let's say at SOC level, the very same module, the driver of very same module will be another module, let's say module B, and it will be the driver. So these two are submodules at SOC level, and it will be the driver of module A. So here, in this particular case, you will have a separate test bench that will have a sort of bunch of other modules, and in this case, you will not write. Uh, Suppose if you want to observe what is going on with the module A, so you could reuse that particular UVM you created at the component level. You could use, let's say that, let's name it UVM1, and you could reuse that particular UVM test bench again at that level instead of creating another UVM test bench. But this time you will use that very same UVM test bench with passive agent. And as I have mentioned earlier, that in passive agent, only there will be an instance of monitor. So in this case, you will be only observing the response of that module A. So in my example, I will use my system verilog adder example, and it is going to be a very simple. So there are lots of ways of configuring the agent as active and passive. In this way, this is the most simplest way, and in this way I will write another UVM object, and that object will work as a configuration for our agent of the UVM test bench for a simple adder. So let's begin. So I will just create a new SV file. So let's call it agent config, and the extension should be .sv, obviously. Let's open it, and we will have the power to configure the agent as active or passive from the test class. And there will be multiple instances of this particular uh, object. So there are going to be two instances in total. The first instance will be in the test, and the another instance will be in the agent. And we will pass the configuration as an if-else statement. So without any further delay and confusion, I will begin. So uh, let's name it same as the SV file, and this should be a UVM object. So the very first thing we have to do is to use uh, the inbuilt enum type, which is found in system in UVM libraries, and that enum is UVM active passive enum. So we will use that particular enum type, and we will write a variable. Let's name it is active. So here I am giving the default value. So this particular enum has two possible values. The first one is UVM active, and the second one is UVM passive. So as you can see it with the name, if it is UVM active, then it will work as an active agent, and we will have instances of each three of the components. Those are sequencer, driver, and monitor inside the agent. But if it is passive, then we will have only a single monitor instantiated, and there will be no instances of sequencer and driver. So let's say uh, the default value for this is UVM active. So after writing the default value, let's do the factory registration. So uh, we will have three arguments for field registration for an enum type variable. So let's begin with it. So inside this, we will write the name of the class. So here uh, we will use the registration for enum this time. So In my sequence item, I was registering the logic variables and I used int for that. But since this is an int type, we will have int, we will have enum for this case. And in our previous case, also we had two arguments. The first argument is of course the variable itself, and the second argument is the types you want to use. Like I'm using UVM default here. We can use UVM all. So here um, I will write UVM field enum, and we will have three arguments. The first argument is going to be the type of the enum, which is UVM active passive enum. And the second argument will be the variable, which is active. And the third argument is, yeah, I mean, what you want to use. I am using UVM default so that we could use methods like print. So after this, we are done with the factory registration. And yeah, one more thing, we will also write the constructor, and we have to explicitly uh, call the uh, parent class constructor. Let's name it same as the class. So now we are done with our agent configuration UVM object. So first, I will just include this inside my packages so that I could compile it. Yes, and let's write include it after the sequences. Okay, so let's compile the top level because top level module has packages inside it. So let's check whether we have made any typos. Okay, it is just fine. So after that, we will move to our agent class. And inside the agent, we will write a condition. So inside the agent, the build phase of the agent, we have instantiated the objects using the create method for driver, monitor, and sequencer. So here we will write the condition for sequencer and driver. So I will put the monitor away. But firstly, uh, let's just write the handle for our agent config, and the name of that is agent config. And let's just name it ACFG. And before that, uh, I would like to add the same thing inside the test component. Where is that? Here it is. So here I will add it. And then you have to use another UVM configuration database. So using that UVM configuration database, you will put it, uh, I mean, you will use the test component to put the uh, the modified value of the agent config object inside the config DB, and the agent class will access it using the get method. So let's begin. First, inside the build phase, let us just create uh, an object using the create method for the agent config. Let's just give it CCFG. So after writing this, what we can do, we could just modify the effective variable uh, which is present inside the agent config. So we could access it and we could modify it using the test class. So let's do it. And let's say for our first run, we want it to be active. So I will write active. Even if I don't write it, the default value is the active only. So we could also change it to passive, which we will do after our first run. And then after doing the modification with the configuration, we will put it inside the config DB using the put method. So of course, the first argument is going to be the type, which is agent config. And then using the set method, so let's say it begins from this, and the scope is from agent. So agent comes under environment, and the handle for the environment is E, and the handle for the agent inside the environment is A. After this, we will write the key. Let's name it same as the handle name, and then the handle itself. So we just wrote an instantiation for the agent configuration object. We modified the isActive variable enum, and then we put it using the set method inside the configuration database. Now the agent class will retrieve that using the get method, and depending upon that, that agent will instantiate the sequencer and driver. That is, it will decide that whether it is an active agent or a passive agent. So let's get back to our agent class. So inside our agent class, the very first thing we are going to do is to check whether that particular UVM configuration database for the agent lies or not. So here we will write a check, and if that is the case that we did not find any entry inside the configuration database, then we will simply write a fatal. A fatal will be encountered and the simulation will terminate. We will use the get method. Let's say it starts from here, and let's leave the scope to empty. Then we have to write the correct key, and in the test we write the key as ACFG, and then the handle of the object, which is also ACFG. So if that's the case that there is not any entry in the database, then we will simply uh, quit the simulation using the UVM federal. Let's say agent config does not exist. So after the configuration database check, we will put the instantiation sequencer and driver inside a if condition. And monitor will be instantiated regardless whether the agent is active or passive. So we will leave it outside of the if condition. So inside this, we will reference to the handle ACFG, and then we will reference to the particular enum variable that we wrote, that is active, which we are modifying inside the test class, and it has a default value of UVM active. So if is underscore active, if if is underscore active is equals to UVM active, then the um, instances or object inside the agent of driver and sequencer will be created. Otherwise, only monitor object will be created. And we will do the same condition. We will write the same condition right here, because there are there isn't there aren't going to be any instances of driver and sequencer uh, in case of an passive agent. So if that's the case, then there won't be any connection between sequencer and driver, of course. So we will write another if else statement right here, and it will have the same condition. Sorry, it should be is active. If and only this configuration is active, then there will be a connection between driver and the sequencer. And the other thing is, of course, there will be an instances of driver and sequencer inside the agent component. And this is our the configuration database check. After we are done with this, we have just completed our entire code. So let's compile the top to check for any possible compilation error. Okay, there aren't any compilation errors, so let's start the simulation engine. Let's run it. Okay, what we have here. So since our agent is active and this particular UVM test bench is working like a regular test bench, and we have 54 UVM infos, no warnings, and it is just a regular UVM test bench which we have created uh, in our adder UVM playlist. So yeah, it is working like a regular test bench. So now, just by accessing the test component, you could make this agent passive. So here, this time I will just change the value to passive, and then I will put it inside the UVM configuration database. What will happen after that? Then inside our agent component, it will check for the particular condition. It will see that this condition fails. So since this condition fails, this particular block will not be executed, and this particular block will also not be executed. So there won't be any driver or sequencer instances inside the agent. So let's see what will happen. We will run the simulation again, and before that we will compile it again. Okay, let's see what is happening right here. So of course, simulation is getting terminated without any reporting macros. These three macros are the essential macros which will execute regardless of how many macros you have inside your UVM test bench. So we are getting one UVM fatal, and it is the code is exiting. What is happening? Here you can see sequence. Neither the item sequencer nor the dedicated sequencer has been supplied to the start items in sequence. Oh, so what is happening right here is that inside the sequence, we will load inside the sequence, inside the test, inside the run phase of the test, we will use the sequence to start the sequencer, but it causes an UVM fatal because after the start, inside the agent hierarchy, the environment did not find any instance of sequencer. It is because of the fact that our agent is configured to be passive, and this particular variable of passive and active agent works as in condition inside the agent, which we just discussed. So there are no instances of driver and sequencer, thus making this agent passive. And for the very same reason, we are encountering this fatal and the simulation is quitting. So that's all about active and passive agent. I hope you find this lecture useful and stay tuned for more. Thank you so much.